Hello students, today we are going to discuss about the isoenzymes. It may be termed as the isoenzymes and they have the different chemical and the physical properties. Isoenzymes or the isozymes are multiple forms of same enzyme that catalyze the same chemical reaction. They have the different electrophoretic mobility, they have the different kinetic properties as well as the amino acid sequence and amino acid composition may differ. Now the very common example of the isoenzymes are the isoenzymes of lactate dehydrogenase. Lactate dehydrogenase is an enzyme present in a wide variety of organisms. Here at first we have to find out the IUB naming of lactate dehydrogenase. Here we can see that is EC1. It indicates that it is a oxidoreductase enzyme. At second step EC1.1, it indicates that it acting on the CH and OH group of the donor. At third step we can see that EC1.1.1, it indicates that with NAD or NADP as acceptor it is at EC1.1.1.27, it indicates the full name of L-lactate dehydrogenase. Here for two subunits are present. M, that indicates the muscle subunit and it is from the chromosome 1, and another subunit is the heart subunit. It indicates the chromosome number 12 and it is acidic in nature and we denote this subunit as the H. Now lactate dehydrogenase reversibly converts lactate to pyruvate in different tissues. And it have five isoenzymes or isozymes, and we can write down that isozymes like LDH1, LDH2, 3, 4 or 5. These isoenzymes are separated by cellulose acetate electrophoresis and the pH is maintained at 8.6. For normal values we can see that the serum value is 100 to 200 U per L, and say for serum it is 7 to 30 and for urine it is 40 to 100. Now this is the reaction how the lactate dehydrogenase reacts. So we can see that L-lactate by the help of lactate dehydrogenase and in the presence of NAD plus it is acts a coenzyme, and at pH 8.2 to 9.8 it is converted to pyruvate as well as NADH plus H plus, and for the backward reaction the pyruvate is converted to lactate at the pH 7.4 to 7.8. Now these are the LDH isoforms. Here the pink color indicates the heart subunit as well as the blue or sky blue color indicates the muscle subunit. And the isoenzymes of the lactate dehydrogenase, we can see that at first we are discussing about the LDH1 and it bears the 4 subunits and all the subunits are from the heart subunits. Then we can write down it as H4 and it is found mainly in heart and kidneys. At the second step we can second type we can see it is LDH2 and one heart subunit is replaced by the muscle subunit and it bears the 3 heart subunit and 1 muscle subunit, and it is found mainly in the red blood cells, heart, kidney and brain. The LDH3, it possesses 2 heart subunit and 2 muscle subunit and it is mainly found in brain, lung, white blood cells and etc. And the third one, that is LDH4, it has 3 muscle subunit and 1 heart subunit, as well as it is termed as HM3 and it is found mainly in the lung and skeletal muscle. And the fourth one, that is the M4 and LDH5, the isoenzyme, it is present mainly in skeletal muscle and liver, and all the subunits are muscle subunit. Here it is the a table which represent the name of the isoenzymes, its composition, electrophoretic migration present in which organ, and elevated level at which. We can see that LDH1 and it is a heat resistant, and composition as the previous slide indicates that it is H4, and it is present in myocardium, RBC and kidney, and the elevated level, it has an elevated level in myocardial infarction. The LDH2, it is H3N1, it is present in red blood cells as well as in kidney, and whenever the kidney disease, megaloblastic anemia, the level of LDH2 is elevated. LDH3, it is present in brain, and the composition is H2N2, and in case of leukemia and malignancy, LDH level is elevated. The fourth one, that is LDH4, and it is named as the H1N3. It is present in lung and spleen, and elevated level we can found in case of pulmonary infarction. And the LDH5, that is M4, and slowest, it is electrophoretic, it is slowest moving, and it is found in skeletal muscle and liver, and elevated in the kidney disease and megaloblastic anemia, leukemia. It is elevated in the skeletal muscle and liver diseases. So clinical significance of LDH, that is in normal serum LDH2 level is predominant, and LDH5 is rarely seen, but in case of myocardial infarction, LDH1 levels are greater than LDH2. In case of megaloblastic anemia, 50 times upper limit of LDH1 and LDH2 is occurred. In case of muscular dystrophy, LDH5 is increased, and for toxic hepatitis with jaundice, patient is diagnosed as a 10 times more LDH5 level. In case of renal disease, tubular necrosis, or in pulmonary embolism, LDH3 is found, and it is massive destruction, for due to massive destruction of the platelets. Total LDH is increased in neoplastic diseases. LDH5 is increased in breast cancer, malignancies of the CNS with prostatic carcinoma. In leukemias, LDH2 and LDH3 levels are increased. In malignant tumors of testes and ovaries, LDH2, LDH3, LDH5 levels are increased. In CSF, bacterial meningitis, LDH4 and LDH5 level is found, and in viral meningitis, LDH1 level is elevated, and in metastatic tumors, LDH5 level is elevated. In neonatal cases of intracranial hemorrhage associated with seizures and hydrocephalus, there also the LDH level is increases. So here the second enzyme, that is creatine phosphokinase, and we can write down it is the CPK. It catalyzes creatine to creatine phosphate and creatinine to creatine phosphate, and the normal serum value is 15 to 100 for males and 10 to 18 unit per liter for females. And CPK consists of 3 isoenzymes, and each isoenzymes of creatine phosphokinase is a dimer, and molecular weight is 40 kd, and the subunits are called B for brain, and it comes from chromosome 14, and second subunit is M, that is for muscle, and it comes from chromosome number 19. This is the reaction, biochemical reaction, which involves the creatine phosphokinase and conversion of creatine phosphate, conversion of creatine to creatine phosphate, as well as the for formation of the inorganic phosphates. Creatine phosphokinase, it is an important enzyme in case of energy metabolism and immediate source of ATP in the contracting muscles. Three isoenzymes we can name as, that is CPK1, CPK2 and CPK3, and CPK1 also called CPK and it is found mostly in brain and lungs, and CPK2 it is called as CPKMB, and third one is the CPKMN, it is mostly found in skeletal muscles. It is a table which represents the different isoenzymes or CPK, different subunits present and the percentage in serum. CPK1 it is bears the subunit BB, which indicates the brain subunits, and it is found in tissue, whereas the CPK2 it is found in the heart tissue. And the first one we can see that first CPK1, first isoenzyme, it is found in brain tissue, and CPK2 it is found in heart, and the CPK3 it is found in the skeletal muscle and bears the two subunits, and both are the muscle subunits. Now this is the clinical significance of CPK. CPK2 isoenzymes are very small and undetectable in plasma. In case of myocardial infarction, CPK2 level are increased within 4 hours, then falls rapidly, and total CPK level is elevated up to 20 folds in myocardial infarction. CPK and muscle disease, CPK level is elevated in muscular dystrophy. CPK level is highly elevated in fracture, acute cerebrovascular accidents. Estimation of total CPK is employed in muscular dystrophies, and CPKMB, that is the second one, is estimated in myocardial infarction. Now here the atypical forms of CPK. One is the macro CK or CPK, and it is formed by aggregation of CPKMB subunit with immunoglobulin G and sometimes with immunoglobulin A, also formed by complexing CPKMN subunit with lipoproteins, and electrophoretically migrates between CPKMB and CPKMN, occurs frequently in women above 50 years. And the second, that is CKMI, it is mitochondrial CK isoenzymes, and formation it is present bound to exterior surface of inner mitochondrial membrane of muscle, liver and brain, and exists in dimeric form and oligomeric aggregates, and molecular weight is 35,000. Electrophoretically migrates towards cathode and is behind the CK and CKMN band, and it is not present in normal serum. Clinical significance, it is present in serum when there is extensive tissue damage causing breakdown of mitochondrial and as well as the cell wall, and presence in serum indicates the cellular damage seen in especially in malignancies. Thank you.